So this is the problem that we are going to look into. So the problem goes like this. We have three cylinders and the weight of each cylinder is 100 Newton and the diameter of each cylinder is 80 mm, and all these things are placed in a channel that has a width of 180 mm. So basically I've asked to find out what is the reaction forces that are present between the bodies. So which means you have a reaction force over here, you have a reaction force over here, you have a reaction force over here, and over here, over here, and over here. Okay. So these are the reaction forces which are highlighted in blue are the ones that you have to find. So this particular problem will be falling under the category of symmetrical problem. So which means I just take this particular plane. So whatever is present on side 1 will be equal to the values that are present in the side 2, which basically suggests that side 1 is actually the mirror image of side 2. So basically that will ensure that the values in what is that 1 will be equal to the values that are present in this particular point 2. Okay. Right. So now what is that we are going to find over here is the reaction forces. So now we have started with the free body diagram for the ball A, right? So the free body diagram, we have just considered that body alone. We have considered all the external forces. So here the external forces are very simple. R1 is one, R2 is another external force. R1 is actually the reaction force that is exerted by the ball A on ball B, and obviously this reaction force will be equal to the reaction force by ball B on ball A. So that is termed as R1, and R2 is exactly the reaction force that is offered by ball A to ball C, and then this is obviously equal to the reaction force offered by ball C on ball A. Okay, so you have three reaction forces, so which means you can get into the Lami's theorem. You have three forces and all these are coplanar, and then you're going to find out the values. So the next point that we have to going to look is this particular angle theta 1. Okay, so theta 1 is actually the distance, or sorry, the angle that is created between P, O and S. Okay, so how is that we are going to find out the value of theta 1? The values are given to you. If you consider this particular distance from P to O, this is the distance. So from P to this intersection point, it is actually the radius of one ball, and from this intersection point to point O, it is actually the radius of the another ball A. So which means it is R plus R, and obviously the radius of all the three balls are equal. So the radius value, or let's say it becomes the diameter, so hence you are going to have the value as AT. So next is you have to find out the distance PS. Okay, so this particular thing is given to us, 180 mm is given to us. So from this point to this particular point, the distance that they have referred is 180 mm. So from this point to this particular point, it is going to be 90 mm for sure. The reason being that S is actually the midpoint. I've already told you in the initial case that this problem is a symmetrical problem, so which means S is obviously a midpoint. So from this particular point to this particular point, the value is 90, but from that pressure point to the point P, it is actually a radius of this particular circle, and the radius value is half of the diameter. So diameter is 80, so the value of radius is 40. So what is this particular value, right? I'll write it over here. So PS is actually the radius value, which is 40, and then you have another value as 90. It should be the vice versa. It is minus 40 and then plus 90. So you're going to have a value as 50, right? So PS value is 50. I'll repeat it. From this particular point to this particular point, the distance is 90 because it's the symmetrical value or the midpoint. From this particular intersection point to point P, it is actually the radius of the particular ball or sphere B. So from point P to S, it is actually 90 minus the radius. So that is what I have written over here, 90 minus the radius, 90 minus the radius. So 90 is from here and the radius is over here. Then you have found out it is going to be 50, and then I have written it down over here. So then finally it takes us to another case where you have to find out the value, and here it is opposite and 80 is the hypotenuse. So I'll be going to sine theta 1, that is opposite side 50 and the hypotenuse side is 80. So obviously you'll be able to find out the value of theta 1, that is 38.7 degree, right? So you have found out what is the value of theta 1. Now we have to take it to the problem, right? So theta 1 is known to you. So from this particular point, how is that they have gone to this particular case? They have just extended that. Already we have discussed what is lines of action of force. So they have extended this particular force and then they have mentioned that as R1. They have extended this particular force along its line of action and this has been mentioned as R2. So this value theta 1 is known to us, that is 38.7. So then the rest of the calculation is done accordingly, right? So if you want to be said elaborately, you just have to consider the axis, okay? So this particular angle can be found out directly, which is actually 90 minus theta 1. So this angle can be found out, and then this value is also known to you. So which means you can find it out over here. And over here the angle is as given 38.7 degree, and over here it is 38.7 degree, right? So if you want to look into detail, you can always refer the other textbook, but I'm not going to elaborately discuss about this particular concept wherein we are going to deal with the angles that has been. So we are not going to discuss about the angles that has been created over here. If it is needed, we'll discuss that in the class. So this is going to be my R1 and this is going to be my R2. So then this is actually twice the angle that is being caused, that is 38.72, and then you have this value. So you are referring into the Lami's theorem and then you have found out what is the value of R1. And similarly, if required, you can find out the value of R2. R2 also will be equal to the same value of this R1, and R2 are going to have a same value of 64 Newton. I have not written down the equation because both these things are just one and the same. That is 100 into sine 38.7 divided by sine 141.3. So which means both these things are just one and the same. So you have found out what is the value of R1 and R2, right? So as of now, what we have done is very simple. We have found out what is the value of your theta 1, right? Once the value is found out, then we just found out the other values and then we have substituted that. So in the next slide, what we are going to look is how is that we are going to go to the rest of the problem. Okay, so here I've just left this blank slide. So if you want, you can obviously write down the equilibrium forces, that is f of x is equal to 0 and f of y is also equal to 0. Write sigma f x is equal to 0. Here you are going to have R1 cos, and this is the value that you have to find. Okay, so if you want, you can calculate that. You are going to have a value as 51.3, and then this particular area you are going to have R2 cos 51.3, and then here you are going to have R1 sine 51.3, and similarly you are also going to have R2 sine 51.3. So sigma fx, you are just going to have two forces. So it is R1 cos 51.3 minus R2 cos 51.3. That is equal to 0. And sigma f y is equal to 0. There again it is R1 sine 51.3 plus R2 sine 51.3 minus the weight, that is 100 Newton, that is equal to 0. solve it, again you're going to get a value R1 is equal to R2, but you're not going to get it as 64 Newton, but rather you're going to get a value in the calculator as 64.07 Newton. It is not at all an issue. The difference is very minimum, right? So this is with respect to the second ball that we have considered over here, but you should be well aware when you are considering either ball B or ball C, you just have to calculate any one, but over here you are not going to have three, but rather four forces are there. That is R3, R2, the weight 100, and then R4. So if you look into this particular side, you will be able to identify I have combined R4 and 100. Whether it can be done? Yes, it can be done. The reason why I've combined this is very simple. Both these things are just lying in the y-axis, but out of this, R4 is the only unknown, whereas 100 is actually numerical value, so there's no issue in that. You can obviously do it, right? So this is actually the Lami's theorem. Then again, I'm not going to explain how that angle is being calculated. If there's any issues regarding that, we'll be able to discuss that in the class. So we have gone for the calculation and then we have found out the value of R4 and R3. Okay, so I hope you will be able to find out the angle, that how it is being done. So if there's any doubt, you can always post it in your courses. I'll be able to help you out, or you can obviously ask your friends and then you can find out how the angle is being calculated other two forces according to the sine law. Now with that we'll be getting into the last part, wherein again you can solve this problem by sigma fx and sigma fy being equated to 0. Okay, so if you're going to equate sigma fx is equal to 0, already you have one force, that is R3, and then you have to calculate this force, that is going to be R2 cos 51.3. I'm sorry, it's 3. R2 value is already known to us, so which means R3 minus R2 cos 51.3 is equal to 0, out of which this is known to us. So R3 is equal to 64 into cos 51.3. Find out the value, you will be able to get it as 40 Newton directly. So this is the value of R3. So if you are going for sigma Fy is equal to 0, you are going to have R4 minus 100, that is this particular force, I am writing it down, R4 minus 100, and then you have another force, that is the vertical component of R2 sine 51.3. So that will be acting in the negative direction, so it is R2 sine 51.3. So R4 is equal to 100 plus R2 sine 51.3. So if we calculate that, it is 100 plus 50, you are going to get a value of 150 Newton. So if you compare this value, R3 is 40 and R4 is 150 Newton, you compare it with the previous slide, you will be able to get the same answers that is present in your Lami's as well as your equilibrium of forces. So I hope that these two videos where we discussed two problems which were actually complicated level on the higher side, I hope you could have got some idea of how the problems can be approached. Okay, so basically before ending this particular slide, there are a few things that you have to look, or that we have to look into. The first thing is, when you have a problem, you can solve it using either equilibrium conditions, I'm sorry for the spelling, or you can always use your Lami's theory or Lami's theorem for solving the problem. Both these things, according to that, whichever you're feeling comfortable with, you can always solve it. Okay, generally if you are going to solve using the equilibrium conditions, one thing you should keep in mind is the sign convention. I'm sorry, the sign convention is very important. Again, I'll repeat it. If you're having it in the positive side of the y-axis, then you're going to have a positive sign convention. If you're going to have in the negative side of the y-axis, you're going to have a negative sign convention. On the right hand side of the x-axis, again you're going to have a positive sign, and then if you have it in the negative side of the x-axis, you're going to have a negative sign. When you're going to Lami's theorem, another theory, or let's say when you're going to look into the Lami's theorem, you have to majorly look upon the angle on a very proper note, which means you have to refresh your basic trigonometry. There's no other go. If you're not feeling comfortable enough with the Lami's theorem, you can always stick with this particular equilibrium condition. All the problems that we have discussed either in the class or in this set of videos, you'll be able to find that both these things are giving us the same answer. You can solve the problem in any fashion you want to solve it. The only thing, when you're going for equilibrium condition, sign convention is very important. I mentioned that. And if you are going to use Lami's theorem, ensure that you're using the angles, especially your trigonometry and your basic geometry. Both these things are very, very important. If you're not very if you're not very sure of that, it's always better you can refer your basic textbooks. That will give you an idea. So with this two sets of videos, we'll stop our problems with regards to equilibrium condition. Maybe in the next class, we'll look into the other cases and then we'll finish it.